Hello. My name is Ivan Garcia-Mora, and I will be presenting as to why heterogeneous computing is best. Why do modern computers mix both big and small processors? So the idea of using different processors instead of one is that there are different types of programs that you run, and they require different needs. Think of it as a brain, okay? The brain obviously has different parts that obviously you don't have multiple brains that do one specific task. There are separate parts, and that is exactly what a processor would be the equivalent of. It would have both big cores and small cores, as to some require fast and powerful processors. Think of it as our brain as our frontal lobes, which are essential for thinking. And then while others are more repetitive and done more efficiently, such as think as physical commands like eating as eating or just the feel or feeling or feels size cores on the same chip to get better performance and energy efficiency. All right, there you go. So we get to the efficiency wall, or rather, what's it called? All modern devices, so nowadays, from smartphones, gaming consoles, or even now modern AI systems, you can't just get faster by increasing clock speed. If you increase, because there are limitations too. In an ideal world, we could just simply increase the clock speed and there we're done. But no, because we have to worry about stuff like computer, uh, like power consumption, heat, memory bottlenecks. Yeah. So how can we improve? So this is the question that we ask. How can we improve? How can we improve without wasting energy? Well, we use the right hardware for the job. It's like using the right tool for one thing. Say as a go, and we primordial stuff. Sorry, excuse me. Yeah. So, what is the difference between a homogeneous and a heterogeneous? Well, a homogeneous is all cores are identical. It is a simpler design and schedule, but is inefficient for mixed tasks, as it is, well, the jack of all trades, one size, but it does not fit perfectly for one. Think about it this way. If I can get, oh, I can draw. Think of it this way. So we have four, four. So we have equivalent cores. They're all the same size. That would be a homogeneous. It's simple, but not all workload would say. Say, for example, we just have to do a simple background task. Well, we have this powerful core, so that's basically using that. We're using an entire space just for a simple one plus one. Yeah. And now, now wait, let me change the color real quick so we don't get confused. And now a heterogeneous is a mix of units from from the CPU, the GPU, which is which is a lot more powerful than a CPU. And then we have our small cores and our big core. Yeah. And then from there, we would just map specific workloads for the most efficient hardware. Yeah. So from here, what's it called? Though you would be asking, but why would you use one over the other? Well, we're going to get into that later on, but it is both. But yeah, you have to remember, codes can be parallel, repetitive, or lightweight. Then that's the only thing you're gonna do. Then I guess homogeneous would be the best. But if they're sequential, control heavy, or extremely complex, then you would have to use a CPU. I mean, a heterogeneous project. You have to use heterogeneous. my research. Okay, so the state-of-the-art homogeneous from 2010. Okay, and this is from 2010. They were already saying that traditional CPUs cannot be enough, and as now we've seen, clearly you could not be able to design AI with it. Making the branching logic, the sequential code, or for OS tasks. In other words, it's for more simple tasks that don't require the and GPU is for many reported operations. Now, this could be for matrix operations, image loading, simulations, or as like machine learning, or especially as most gamers should know, graphics. Okay. Now, now FPGA is a custom hardware that pipelines for specific tasks, which makes them both efficient but also the most tedious to program with. And since this is custom code, this is specifically reconfigurable hardware. This is for this hardware, which will make it the most efficient, but also the most annoying to program. Now MPUs got now these are extremely what's it got. This is new. I'm gonna write that down so that way we can make the best watts, best per watts. That is going to be essentially the big topic. I'm gonna keep it up. And I am okay. All right. So how much more powerful is a CPU than a GPU than a CPU? If uh, one GPU is the equivalent of 15 CPUs, and a fixed FPGA can be 50 times more powerful than a CPU, which should make you realize how powerful your world, as there are multiple latitude of problems that we face. So now, everyday things that use heterogeneity. Smartphones, as I mentioned earlier, because they use big and small CPUs, the and they have integrated GPUs. They and like I mentioned before, this is why they're better responsive. They have better responsiveness nowadays, better battery life, and better heat distribution. Uh, and scientific high processing computers. Now this one was talked a lot in the state of the art paper, in which they are essentially used for complex things like linear algebra or image processing, FFT, simulations, numerical methods, and graphics and visuals are also used by heterogeneity. I mean, this is a uh, things like SolidWorks, CAD, uh, which make these, which essentially are used to make. Once again, not really that, but now I want to talk about something that's for me, robotics sensor fusion and control loops, in which you run on a CPU. Sensor fusions and control loops can run on the CPU. The vision goes to the GPU. The lo and you could put low power on the microcontrollers and run on the small core, like your Raspberry Pi and yeah. But yeah, re another what's it called? You see how there's like real instances where you use this and it's efficient per voltage. What's it called? Efficient per usage, my bad. I'm sorry. Yeah. All right, so the future, which is obvious. Well, what's it called? It's not, surprisingly. And now, which is why we get to the programming tax, which is essentially saying, while yes, it's a mostly hardware stuff that we've been talking about, there's also a software part. Just a custom code is significantly more complex when if you're running a heterogeneous than a homogeneous. You're controlling, yeah, separate, but separate but equal units. Yeah. Well, not separate equal, but they're essentially all part of the same system. Yeah. A GPU is fast, but if you perform a lot of data transfers, it really taxes up. Yeah, which is why it is essential to have memory programming, memory management. Anyways, well, I do have to say, in conclusion, homogeneous computing is used as identical cores, which are simpler and less adaptable. Heterogeneous computing is for CPU, include CPUs, GPUs, FGPA, and, and big cores and small cores all in the same processor. Matching each, you match each workload to the processor, which can execute the most efficient. So much for your time, and I hope you have a great day.